Day 5. We are shifting gears and we are going to talk about the area and volume of a sphere. Okay, this is going to be very much formula driven. So for these first few problems, find the surface area of a sphere. You just need to understand that the formula for the surface area of a sphere is 4 pi r squared, where r is the radius. So if I want the surface area of this sphere, I'm just going to do 4 pi times 4 squared. Whoops. Okay, so 4 pi times 4 squared is 64 pi. That would be the exact answer. And this would be the decimal answer, 201.06. Okay, and this is area, so the units will be squared. All right, same thing with number 2. We will do 4 pi times the radius squared. There's my radius. So that's going to be 4 pi times, and what was it? 3 over 2. That's what I thought. All right, 4 pi times the radius squared. That's 9 pi, which is 28.27. Square inches. So that's number 2. Number 3, 4 pi. Whoa, be careful. This 14 is not the radius. This is the diameter, so of course that means that the radius is 7 meters. So I will do 4 pi times 7 squared. All right, that's 196 pi, or 615.75. All righty then. All right, that's the answer to number 3. So just use the formula for the surface area of a sphere. Number 4, what is the approximate radius of a sphere with surface area of 40 pi? Look, if they give you some value, substitute it in. Use the formula for that value. So they gave us the surface area. Well, I was supposed to switch to highlighter mode. They gave us the surface area, so the first thing you should do is write down the surface area formula. Okay, so what is approximate radius? All right, so in every case, we are doing surface area. So remember, surface area is 4 pi r squared, like we just did. If the surface area is 40 pi, oh, this is multiple choice. Okay, so if the surface area is 40 pi, then this becomes, if we take that 40 pi and substitute it in, this becomes 40 pi equals 4 pi r squared. So to find the radius, we're just going to solve this for r. So we will simply divide both sides by 4 pi. Okay, because this will all cancel out. That's just going to leave the radius squared. So at that point, we will have radius squared equals. Now, these pi's are going to cancel out. So it's just 40 divided by 4, so that's 10. Okay, so r squared equals 10. How do we unsquare things? We use the square root. Okay, so r is just going to equal the square root of 10, but these answers are clearly in decimal form. So let's check that out. Square root of 10. 3.16. Okay, and that means the answer was B. All right, what's next? In these exercises, we will use the sphere below. The center of the sphere is C. The circumference of the sphere is 7 pi. Circumference. Now look, they're giving us the circumference. So if they give you something, write down the formula for that something. So if they give us the circumference, then let's go ahead and remember that the circumference is equal to 2 pi times the radius. So if the circumference is 7 pi, we will just take that 7 pi and substitute it in. So that's going to give us 7 pi equals 2 pi radius. To get r by itself, we will divide both sides by 2 pi. So this cancels out, and look, the pi's also cancel out. So that's going to leave us with r equals 7 over 2. Okay, and this is a length, so it'll just be centimeters. Of course, we could put 3.5, but 7 over 2 is just as good. So that's the radius. Now, find the diameter of the sphere. Well, we know that the diameter is going to be double the radius. So that means the diameter is going to equal 2 times 7 over 2. These 2's would cancel out, so that means that the diameter is 7. So that's it. The diameter is 7 centimeters. Number 7, find the surface area of one hemisphere. Okay, you need to understand that a hemisphere is half of the sphere. So if this is a sphere, which of course it is, then this is a hemisphere, literally half of a sphere. Okay, back to business. So if I were you, I would just find the surface of the whole sphere and then just take half of it. All right, so the surface area is 4 pi r squared, as we have discussed. So 4 pi times the radius squared. Up here, we saw that the radius was 7 over 2. So I could take this 7 over 2, and I could get it down here. Okay, so this is going to then become, the surface area will be 4 pi times 7 over 2 squared. Oh yeah, oh yeah. So 4 pi times 7 over 2 squared is 49 pi. I'm going to leave it like that for a minute. It says 2 decimal places, but we're not there yet. So the surface area is 49 pi. Okay, but that is for the whole sphere. Whole sphere. Okay, so 1/2 the surface area is going to equal 1/2 of 49 pi. Okay, so we'll just take 49 pi divided by 2. Okay, so divided by 2, man. And that's going to give us 76.96. Whoa, rounding up. So 76.97. All right, so that's 76.97 is the hemisphere. Whoa, what is that? I just invented a new letter. It's the HM combo. Okay. Hemisphere. Okay. So that is surface area. So we're dealing in centimeters, so this will be square centimeters. All right, so if you want the surface area of a hemisphere, find the surface area of the whole sphere and then cut it in half. Easy enough. Oh, a great circle. The circumference of a great circle of a sphere is this. What is the surface area of a sphere? Okay, well, just remember what a great circle is. Okay, this is an example of a great circle. It's the biggest circle that you can make around a sphere. You know, as opposed to, see these smaller rings that I could make, like latitude on the globe? Those are not great circles. There's only one latitude line that would be a great circle, and that would be the equator. Okay, so if you have a great circle that they're talking about, the circumference of that great circle is going to be the same thing as the circumference of the whole sphere. Okay, so any great circle is the circumference of the sphere, which I can then use to talk about other things, like the radius, for example. Okay, so we'll get a great circle, and so we'll just do the circumference sort of like normal. So the formula for circumference, whether it's a great circle or not, is the same as it has always been, 2 pi r. Okay, so once again, this is a situation where they're giving us the circumference. So if they give you something, write the formula and substitute it in. So this will become 24.6 pi is equal to 2 pi radius. Okay, so let's see what we can do with this. We will find r. We will find r by dividing both sides by 2 pi. Like so. Once again, these pi's will cancel out. Of course, this all cancels out. So this is going to give me that the radius equals whatever this is. I bet it's going to be 12.3. Okay, it should be the radius. So now, what do they ask us for? What is the surface area of the sphere? So we had to find the radius first, but now we're not done because we have to go on and find the surface area. You know that the surface area is 4 pi r squared. Okay, so we will just take this and substitute it in. All right, so if I take this radius here and substitute it in right here so I can get the surface area, that's going to be that the surface area is equal to 4 pi times 12.3 squared. Okay, so 4 pi times 12.3 squared. So that's 1,901.17. And this is area, so centimeters squared. All right, that is how you do that. Let's see what's next. Aw, shucks, getting into volume. All right, if we're going to deal with volume, then we need to know the formula for the area of the volume of a sphere, which is 4/3 pi times the radius cubed. All right, that's the formula for volume. So number 9 will become, all right, 2 decimal places. So it's going to be 4/3 pi times 7 cubed. And this one will be 4/3 pi times 9/2 cubed. Don't forget, watch out, this is the diameter. that means the radius is only 8. So this one will be 4/3 pi times 8 cubed. All right, so it's just a matter of putting all these in the calculator. So far, we haven't dealt with exponents other than 2 very often. We hit this x squared button a lot. So let me just make sure everyone remembers. If I want to do the third power or fourth power or any other kind of power, I will use this button right here. It's called a caret for some reason. But it moves me up. It kind of looks like an upward arrow, and it does bump us up into the exponent area. And then I can type whatever I want, including third power. So that's how you would do 4/3 pi times 7 cubed. Okay, so for an exact answer, I get this, but I can just toggle it and get this. So 1,436. 0.76 feet. Now, we have seen that length is always regular units, right? So if I have length, then the units would be like, for example, centimeters. If I do area, then the units would be square units, so centimeters squared. If I do volume, then volume is measured in tiny little cubes, and that would be written this way, cubic centimeters. So in this case, this is feet, but it's volume, so it's cubic feet. Okay, and I'm just going to type these all in my calculator the same way I did number 9. I think I'll do that off camera, though. Shabling! So these are the answers that we get if we type these into the calculator. All right, absorb it, soak it in, check your answers. Yeah, so moving on. All right, what else? Find the radius of a sphere given the volume. Round your answer to decimal place. So if you're given something, write the formula for it and plug it in. So we're given the volume, so we will write the formula for volume, 4/3 pi radius cubed. And then we will take this and substitute it in. So this will be 64 equals 4/3 pi r cubed. And this will be 100, whoops. All right, this will be 150 pi. Don't forget the pi. Some kids just leave the pi out. They ignore it. Don't do that. Equals 4/3 pi r cubed. And this one will be 152 equals 4/3 pi r cubed. Okay, so and we're supposed to find the radius in each one of these cases. So we're just solving for r. So what you will do is following. We are going to divide both sides by 4/3 pi. Okay, so I'm going to divide by 4/3 pi over here, and I'm going to divide by 4/3 pi over here. 4/3 pi. That way all this mess cancels out. So that should just leave me with r cubed equals whatever this is. Okay, so let's see what that is. So 64 divided by 4/3 pi. That shouldn't be hard to type in the TI-30XS multi-view. We do 64 divided by, okay, and then we can make another little fraction and do our 4/3 pi. I guess that was it. All right, 64 over 4/3 pi. Let's see what this looks like. Okay, it goes straight to a decimal. So there it is. Now I'm going to go ahead and write this down. Then I'm going to show you a trick to avoid having to round right now, because I really don't like rounding when it's not the final answer yet. What was that again? 15.28, let's call it for now. So we have 15.28. Okay, but we still need to take the cube root of this mess to get r by itself. That might be new to you. You know that if we had, let me just do this in a different color for a second, off to the side. You know that if I had r squared equals 15.28, if I wanted to unsquare this, I would take the square root of both sides, right? And that would cancel out the 2, and I would just have r equals whatever I got. What you may or may not know is that this is a square root means a second root. So there's an understood 2 right here. If it's blank, it's understood to be a 2. That's why it undoes squaring. But you can do any kind of root. So if you want to undo an r to the third power, then you will need a third root. And you do have to write the little 3 in there. So that's what we're about to do right now. That's what we are about to do. So we're not doing the square root. Oh no. We are doing the cube root. The cube root. Okay? So I need to do the cube root of 15.28. Okay? Now, the way I do a cube root is, first you type the 3. Like this. 3. Now, I'm shooting for this right here. See this little X root in green above the button? You had to type the 3 in first so the calculator would know what you wanted the root to be. But now if I hit second and I hit this caret, it becomes a cube root. Now I'm ready to type all this in. Now, I really don't want to write 15.28 because I'm rounding and I don't like that. I want all the decimals. Now, I could sit here and type in a bazillion decimals. But whatever's the last answer you got, it's automatically stored in this ANS. So if I hit second and then I hit the minus sign, what it's really typing in right here is 15.27887574, and all of that. So when I do this, it just took the cube root of this whole number with all of its decimals. So this, well, let's see how close this is if I had just typed in 15.28. Okay, so let's do that again. Remember, if I type 3, and then if I do second caret, I've got my cube root. This time I'm going to try typing in 15.28 so I can compare. Okay, so it's pretty daggone close. So we had 2.4814 like that, and then we had 2.4814, and then the numbers changed around this area. All right, so if you don't remember how to do the ANS thing, you could probably get away with doing it this way. Anyway, so our radius is approximately 2.48. Okay, and that's what we were supposed to find, so we're done. Okay, so 2.48, and this is inches, will equal our radius. Okay, I'm going to do the other ones quickly now that you see how to do it. I'm going to show it one more time. Okay, because this is, some of that was new to some of you. So again, if I want to get r by itself, then what I need to do is divide both sides by 4/3 pi. So I'm going to divide by 4/3 pi on both sides right now. 4/3 pi. That way all this cancels out, and that is going to leave me with r to the third power equals all of this. Now this one is a little different than last time. 64 didn't have a pi on it. This has a pi on it. So because of that, these pi's will cancel each other out. So when I go to type stuff in my calculator, I'm just going to type 150 over 4/3, like this. 150 over, I'll hit that again so I can do 4/3. Okay, that gives me this. Okay, and I could go ahead and toggle this. So that's 112.5. Okay, now how do I get r by itself when it's cubed? Again, you can uncube something using the cube root, like this. Now, do you remember how to put this in your calculator? All right, cube root of 112.5. Okay, remember you have to hit the 3 first, and then you hit second, hit that caret, and that will give you the cube root. So that was 112.5, I do believe. That gives us this, 4.83. Okay, and that is centimeters. So that would be your radius for number 13. Looking at number 14, let us divide once again by 4/3 pi on both sides. Okay, all this will cancel each other out. 152 divided by 4/3 pi. Okay, let's see what we got. So that's 36.29. Okay, so that equals r to the 3rd power. How do we uncube things? We do the cube root one more time. So cube root, cube root. So the cube root of 36.29. Okay, 3 first. Second caret, 36.29. Is that right? Yeah. All right, so the cube root of that gives me 3.31. Meters. So that would be the radius for number 14. Okay, that is how you do that. Let's move on. Got to be almost done. Oh, this is the last one. Check us out. We're awesome. So looking at number 15, what is the approximate radius of a sphere with a volume of blah, blah, blah? So 128 pi. If they give you something, use the formula for it. So in this case, they gave us the volume right there. So if they're going to give us the volume, we're going to start off by writing the volume formula, which is, of course, 4/3 pi r cubed. In fact, is this any different than what we've been doing? What is the radius given the volume? All right, this is exactly the same as what we just did. It's just multiple choice. So same exact thing one more time. So 4/3 pi r cubed. 128 pi is the volume. So I'm just going to take this, put it in for volume. So that's going to make 128 pi. Please do not leave off the pi, as some of my wonderful students often do. 4/3 pi r cubed. Then we need to divide both sides by 4/3 pi. That way all this cancels out. Notice this time there's a pi there. So these pi's will cancel out. So I'm just going to type in 128 over 4/3. So 128 over 4/3. Okay, that turns out to be 96. So that gives me that 96 is equal to r to the 3rd power. How do we uncube things? We do the cube root one last time. That will get r by itself. So if we take the cube root then that's going to give us just plain r, because these cube root and the third power undo each other, and I just have r. It's an r, by the way. So I just need to do the cube root of 96. Okay, one more time to do the cube root on the TI-30XS Multiview. You start by typing 3, and then you do the second caret to get at that x root business. And now I can just go ahead and type in the 96. So that is 4.5, and I'll have to round this up to an 8 because the next number is an 8. So 4.58. Okay, and that should be centimeters. Okay, and there it is, the answer is B. All right, that is our lesson. I hope that was helpful to you. If it was helpful to you in any way, please give me a thumbs up, hit me that like button, and that will let me know that my services here are appreciated. In the meantime, I will see you on the next video.